Can we hook all this up to an assemble yourself power station? Let's give it a try. Hey guys, Random Gene here. Hope everyone's doing well. So I wanted one of these 12-volt power stations for a while. You know, something you could charge USB devices from, plug 12-volt devices into it, maybe even a couple of small wattage 120-volt devices. Anyway, I figured instead of buying one, what fun is that? Let's build one. So I accumulated all the parts. I think I have everything I need in the garage, so let's go ahead. Let's get to it. I have a Renogy lithium iron phosphate 12-volt battery. It's a 50 amp hour battery. We have a Renogy solar charge controller, a 400 watt true sine wave power inverter for 120 volts. We have a 120 volt to 12 volt charger for the Renogy battery, and a 110 watt folding solar panel. Powerwerx made this box. They put all the accessories on it. I'll go over it in more detail in a bit. I figured for the price of this already assembled, it was just more economical for me to purchase. And I pre-made some cables in anticipation of needing them, and a couple other adapters and whatnot, and we'll go over that as I put this together. All right, showing it to you quick. Over here is a Type C charger, a quick charge 3.0 USB charger, and in the center there, you'll see it later, that will give you the light up the voltage of the battery. Over here is a 2 USB 4.8 amp chargers. This is a 12 volt automotive socket, standard cigarette lighter type plug. Over here are 8 power pole connectors and 2 binding posts. Now the power pole connectors are protected with 40 amp fuses. The binding post is protected with a 40 amp fuse, and the circuit breaker switch, which provides power for these 3, is a 15 amp breaker. Let's open it up. This, a 40 amp fuse for the binding posts and the 4 power pole connectors, and the rest is protected by this 15 amp circuit breaker switch. There's a work light switch to turn it on and a switch to change modes. I did pre-drill some holes in the side of this with anticipation of mounting a power inverter. So here you can see I put the battery in the box. This power box was actually designed by Powerwerx for a different brand of battery. Well, this is the battery I have. I'm going to make it work some way, but when you try to close it, it doesn't close all the way. What's happening is the battery is too high, and all these connectors here are preventing it from closing, but there's a way around it. I went to my good friends at Ray's Lexan Cutting and had them cut a spacer, and I'm going to mount that spacer underneath this panel here, which will raise it and give me the clearance to put the battery in. Spacer installed. Notice it's closed with the battery in it. It raised this up, lets it clear the battery. We can close it now. All is well. Thank you, Ray's House of Lexan. Here we have the Wagon Tech Elite 400 Watt Pro DC to AC pure sine wave inverter with a 50 amp hour battery. You want to kind of keep it at about 300 watts. I'm going to mount it. I'm planning on, what do you get here first of all? You get the inverter. And get some cables in a book. Alright. I have the 120 volt pure sine wave inverter mounted onto the box. Very simple. Couple of screws, nothing fancy. I also have this connector I made up. This will connect the power inverter to the battery. I ran the battery cable for the inverter through the box, with the grommet. It's coming through the box, waiting for connection to the battery. Okay, so I have the battery placed into the box. I have some styrofoam spaces here just to prevent it from moving around while it sits in the box. I have two cables that I pre-made with some connectors, and they will go to the battery terminals. One will connect to the inverter, and the second cable will connect to the actual accessory ports on the power box. This is fused for the inverter. This one is not fused because there's already a fuse here that came with the box. So let's get those connected up. So I have the battery terminals connected to the cables. So two connectors, one for the power inverter, which we'll use here, and another for the accessory ports on the power box. And we're live. We just need to turn it on and give it a shot. All right. Well, like I said, there was a voltage monitor here, so let's turn it on. There you go. If you can see that, 13.4 volts. So everything here is live right now. The power inverter is controlled by its own switch here. If you turn it on, there it is. Power inverter is live also, so you can plug in a couple of 120 volt appliances. Up to 400 watts, but I wouldn't go more than 3 like I said earlier. Okay, let's check some voltages quick. Turn on the power box. Let's see at the binding posts. Polarity is good, 13.52 volts. How about the power poles? 13.53 volts. Perfect. So we are good to go. And we have 13.5 going to the inverter. Yes, we do. Perfect. Good. Before we go any further, allow me to show you this fancy light that's on the box. I don't know. Oh, we can change it. There's supposedly there are 10 different types of flashing. Try to get to solid. Yellow is on the left, white is on the right. There you go. There's solid. Well, you get the idea. So we had 13.5 volts on the battery when we tested it before. And from 13.5 to 14.6, you're pretty much at a fully charged battery. So what we have here is the C-Tech 120 volt battery charger for this. So to speak, we'll top it off. But the C-Tech Smart Lithium Iron Phosphate Battery Charger, 4.3 amps. We'll take it out of the package, we'll hook it up, and we'll see how it goes. Got the user manual, the outlet. So, comes with a couple of various ways to connect it. Hardwire it to the battery. This would go to here. And this would connect to your battery. We're not going to go with a hard wire on that. I am going to go with the alligator clips, and we'll charge it right through the binding post. Because if you remember what I said before, these 3 accessory ports, the 2 power pole ports, and the set of binding posts, they're wired directly through the battery, protected by a 40 amp blade fuse. So we will ultimately unscrew this, and we will connect it like this and charge the battery up. Okay, I have the C-Tech charger plugged into the outlet. It's powered up. I'm going to connect the battery connecting alligator clips. Connect it there. We will connect it to the battery for charging. So this is a Looks like an 8-step battery charger. Lithium iron phosphate batteries have a very specific charge profile they like, and this charger will perform that exactly how the battery likes it. Gonna let that sit. We'll come back later when it's charged up fully. And it shouldn't take long because it was already at 13.5 volts. We are fully charged at profile number 7. Number 8 is a pulse charge, and that is to maintain the charge. If the battery voltage drops below 13.5 volts, it will pulse charge it at a higher voltage, maybe 14.6 volts. I'm not sure. Either way, that's a charge, but we're fully charged. We should have something between 13.6 and 14.6. Okay, checking the voltage. We are at 13.7 volts. Very good. We're fully charged. Remember, somewhere between 13.6 14.6 volts, you're 99 to 100% charged. That's all very good. I'm not crazy about using these alligator clips, I've decided. So what I'm going to do is I am going to take the hardwire connection. I'll put some power poles on them and charge it through one of the power pole connections. There we go. That's how we'll go ahead and start charging it. Much simpler than the alligator clips. Alright, so going over the power box we just built. That's the inverter, 400 watts. That's where the wires are going into the box. Definitely get yourself a pure sine wave inverter. So let's look in the box first. And what I have here. Oops, excuse me. So I was able to store the battery charger inside, but I will pull those out. What I have is the battery here. Some styrofoam spaces just to prevent the battery from moving around. I have 2 connectors connected to the battery. One connector, you can see, goes through and connects to the power inverter. The other connector, which is connected to the battery, goes to all the connections for the power box. So it's very simple. There's enough room here that I can store the charger in here. And it makes it for a nice little storage compartment. Oop. On the back side of the box, we have the light, 240 amp binding posts, 12 volt, 4 power pole connections, a 12 volt accessory outlet, much like what's in your automobile, a 4.8 amp USB charger, a Type C USB charger, and a quick charge 3.0 USB charger, protected by a 15 amp circuit breaker switch. And that is the power box. So let's get into the solar charging part of this now. So one option to charge this power station will be solar. This is a Renogy Rover Elite 20 amp MPPT charger controller. Much more efficient than a PWM solar charge controller. Manual. The actual charge controller. This is a temperature probe. We're not going to use it in this case. I also went ahead and constructed these 2 pigtail connectors. These will connect to the charge controller. One will be for the solar panel, and one will be for connection to the battery or power station to charge it. This is a cable I also constructed. It's also got the power pole connectors. I'm trying to keep everything power pole. Powerwerx FSP 110 watt folding solar panel. So this solar panel has the cable connected to it already. When I got it, it originally had these standard MC4 solar connectors. And like I said recently, I'm trying to keep everything uniform using power pole connectors. So what I did was I cut off the MC4 connectors from the original cable, and I spliced in a longer cable and some power pole connectors. I can go directly from this panel into the solar charge controller if I wanted to, or I can also use this red cable as an extension. I went ahead and I took the MC4 connectors that I cut off the solar panel cable and effectively made an adapter. So should I ever come across a device that needs the MC4 adapters, I have them ready to go and can use them. I also built a smaller cable, about 2 feet long. Opening this folding panel is straightforward. It's a 4-panel, so not a bad size for a 110 watt solar panel, especially when it's folded. We'll go ahead and connect these pigtails. So I have the MPPT charge controller programmed. It's ready to go. I have it connected to the battery through the cable and plugged into the power port connector up there. The only thing left to do is connect the solar panel. Show you the screen quick. It shows you the battery voltage. It does light up. It shows you the solar panel voltage. That's 0 because there's nothing there. Temperature, if you were to connect the temperature probe. Kilowatt hours, and back to your battery voltage. That's pretty much the assembly and setup. Next we'll bring it outside, we'll hook up the solar panel to it, we'll see if we can get some charging going on with that, we'll plug some devices into it, and I think also what I'm going to connect to it and see how it handles it is this new 12 volt IceCo refrigerator I picked up for the truck. Should be able to run it off of that power station. I do want to point out that I am going to keep the solar charge controller and the cables separate from the power station. I was originally thinking I could mount this solar charge controller somewhere on the box. I guess the only real spot would be here in the front or on the opposite side, but no, I think what we'll do is I'll just keep it separately. I'll put this all together in a nice little, maybe another box or a bag or something, and keep that together. And then I'm not just dedicated to this power station. I can use the solar panel and charge controller and cables for other things down the road. Who knows what? I'll maybe come up with something, but it's available if needed. It's available for the power station to use, and it's available for anything else that comes along the line down the road. So that's what I'll do. Here it is all completed. We have the power station. Inside the power station, I'm storing the battery charger, and I decided to go with a little ammo box here. Just has the items needed for solar charging. So let's go ahead, we'll see what we can do with it. Let me show you what I got here. It's the solar panel, 110 watt. We've got it wired. So let me show you what I have connected to this power station. First of all, I have the solar panel going to the solar charge controller right here. That's going in This is coming out. It's connected to the power pole connector, and that is charging the battery right now. Battery is 13.4 volts. It's charging at 17 volts. I have an amateur radio connected to the binding posts. I have a second handheld amateur radio, and that is connected to the other set of power pole connectors, charging there. Next, we have a cordless drill battery charging, and that is plugged into the inverter here. I have a phone charger plugged into the inverter. That's actually charging my drone controller. I have my phone charging, and that's plugged into the 4.8 amp USB connection. This 12 volt automotive plug is connected to and running my 12 volt refrigerator, and that's holding at 35 degrees. We're even powering a 12 volt ice cold refrigerator. So nice and cool. A couple of White Claws. Anyway, again, we have the refrigerator, cordless drill battery, handheld amateur radio, my phone, drone controller. What else? The 2-meter mobile amateur radio. And there's the charge controller connected to $110-watt solar panel. I hope this video to assemble your own solar power station was helpful in some way. If it was, let me know. If it wasn't, let me know also. Until my next random video, whatever that may be, I hope you all do well, and I hope you enjoyed this. Take care, everybody.